All right, SAT Physics Test 3, number 1 to number 5. Use the following choices for the units below. All right, let's see the first one. So I would like to know the specific heat capacity has what unit. So I'll write its formula out. I know C equals Q over M multiplied by delta T. Now the unit for Q is joules, while the unit for M and delta T will be kg, kilogram, times degree Celsius, and the whole thing raised to -1. So in this case, my answer is for number 5. Number 5 is A. That is the unit of specific heat capacity. All right, let's see heat capacity. So a heat capacity is Q over delta T. Amount of energy you need to put in to cause a change in temperature. In this case, Q has a unit of joules and delta T has a unit of degree Celsius, -1, or you can go with joules. Instead of degree Celsius, you can go with Kelvin. Okay, so the answer for this is for the first one. So number 1, the answer is B. That is the unit of heat capacity, joules per Kelvin. Power, recall the formula for power. P equals F times velocity. Now I realize that the unit for force is Newton. Velocity is meters per second. So in this case, power has a unit belongs to number 2. In this case, the answer is C. All right. Now, latent heat of fusion. This one. Latent heat of fusion is HF. HF equals Q divided by the mass. Q is joules and mass is kilogram. Joules per kg. So the answer for this is number 3. Number 3, the answer is D. All right, last one, number 4. Joules times kg. So joules times kg, let's say we go with Q, multiply with mass. This one belongs to no one in the choice. So the answer for number 4 is E. All right, let's see number 6 to 10. So they want us to refer to the information or to the choice here. Number 6, the diameter of the wire is doubled. What happens to its resistance? We know that R, resistance, is inversely proportional to the radius squared. All right, so in this case, I recall that if I would like to write out the relationship, it will be R1 times the radius 1 squared. That should give me the same value as R2 multiplied with the second radius squared. So for instance, R1, let it be big R. And this radius, let it be 1 squared equals R2 is what we would like to find. Now, if the diameter doubled, radius also doubled. So you double this, you're getting 2 squared. So 2 squared is 4. So my answer for this is R2 is equals to R divided by 4. So it's being quartered. So the answer for number 6 is D. All right, let's see number 7. Number 7 says the height of the balloon increased by 4 times. What happened to its gravitational potential energy? All right, let's see what happens to the gravitational potential. So I'm going to write out the formula for gravitational potential. G PE equals mgh. Now, if the height here increased by 4 times, all right, let's say M and G didn't change because they didn't tell anything about a change in mass or gravitational force. Now, this will also increase by 4 times. So in this case, the answer will be quadrupled. The answer for this is E. All right. So for number 6, the answer is D. Number 7, the answer is E. Okay, let's see number 8. Number 8 says a box of gas is heated, so the volume doubled. What happened to the mass of gas? Remember, in gas law, we are concerned with only pressure, volume, and temperature. And mass is supposed to be kept constant. So in this case, the mass didn't change. So it will go with A. The mass stays the same. Number 9, if PD across the bulb is doubled, what happens to the current? All right. I recall the formula. V equals IR. Now, the question says, if V double times this by 2, all right, the relationship here is directly proportional, which implies this I, let's say we didn't touch R, so we fixed R. If V double, this I will also have to double. So in this case, my answer is C. All right. Last one, number 10. The orbital radius of the planet from the sun is doubled. What happens to the orbital speed? In this case, you have to recall that this relates to delta L, or angular momentum, which is mvr. Okay, so delta L has to remain constant. What's happening right now is if R doubled, so this guy doubled. Now, mass of the planet normally remain constant. So the only thing that has to change in order for delta L to remain constant is this V. This V has to reduce by half. Okay, so we are multiplying these two and we should get 1. Yeah, so we can say V has to reduce by half. So the answer for this is B.